Okay, 7.5, we're dealing with residuals. So we've got a question. I'm going to work questions 9 and 10 from the textbook out so we can see how to utilize everything that you read in this section. So, number 9, bookstore sales once more. Here are the residuals for regression of sales of number of salespeople working for the bookstore of exercise 5. What are the units of residuals? Which residuals contributes the most to the sum that was minimized according to the least squares criterion to find this regression, and which residuals contribute the least to that sum. Okay, so first I'm going to talk about all this information can be deduced from this table. So a residual is the difference between the output uh, of an actual data point and the line that we use to model that. So in this case, let's take a look at the data itself. That will help us. So going into StatCrunch, my output is in sales. So each one of these residuals is the difference between an actual data point and what the model would have predicted. So let's take a look at what the model would have predicted. So I'm going to go to Stat, Regression, Simple Linear. X is my number of salespeople working, and Y is their sales in thousands of dollars. And let's see what else I want. I want to do a fitted line that we want to see that graphically. I'm going to hit my control button. I want to see a residual index plot and the histogram of the residuals. Also, I want to save the residuals themselves. So I'm going to compute this. Now, these are the residuals we're seeing in the book. So for number 1, the residual is 0.07. So that's what this residual is here. So same residual on this table. So this is where the table comes from. So what do these residuals mean? That means for 2 salespeople, we had $10,000 in sales, because that's in thousands. And my residual is the difference between the actual sales and the predicted. And my residual is positive, which means this was 0.07. Let's see, this would be thousands, hundreds, tens. So this would be $72.62 higher than the model predicted. So let's look at the model so we can see what we're talking about here. So here's the model, and you can't really see it because it's very close, but this is the model. So here are my actual data, and this is the best fit line. So a large residual is a point that's going to be very far away from the line, like number 4. And what we're looking at here, when we go back to this number 4, we see the residual is negative 2.3 because the data point you can clearly see is below the line. So when I take the data point minus the y value predicted for the same x value of 9, we get a different than the line, and it's $2,321 in sales below predicted from the line. And another large point would be this point here. This one is $2,765 in sales more than we expected from the line. So the residual that contributes the most when we add all of these up, this is the one on number 6 that's going to contribute the most to the sum, because we're adding these distance squared together. So this will by far contribute the most. It doesn't matter whether it's positive or negative. It's just the distance from the point to the line that we're really interested in. The residual, a positive distance, means my point is above the line. A negative residual is my point is below the line. So this point's below. Let's go. Oops. That point is my point above, and this is my point below. The one that's the furthest distance, absolute value distance, is the biggest here. So let's see what other questions we have. So the residuals are in thousands of dollars. Which residual contributes the most? This one here, because it's the furthest away from the line. And let's see, which residual contributes the least to the sum? So what we're looking at is which of these points are the closest to the line. And let me get rid of this point. What we're interested in is probably this looks real close here, this one here, and this one. These are my points that are the closest looking to the line, and I'm just looking for the smallest absolute value. Doesn't matter whether it's positive or a negative, and it looks like number 1 is the closest because it has the smallest distance from the point to the line, and that distance is my residual, smallest. So it's going to contribute the least. Okay, so let's look at number 10. I'm going to go through the same idea here and see how this works out. Same idea, which residual contributes the most? It's the one that is the biggest number, whether it's positive or negative. In this case, it's the negative 329.8. Now, let's see. I'm going to go ahead and look at the data so I can see what my units are, just so I understand. Okay, so it's the price of a computer's memory storage in terabytes. Okay, so my residuals are going to be in dollars. Yes, just in dollars. What residual? Okay, so the residual that contributes the most is my negative 329.8. And again, let's look at that graphically. So let's go ahead and pull up my regression, simple linear. X is my capacity, Y is my price. I want a fitted line plot. I'm going to go ahead and look at a residual index. Oops, I don't want to do the shift. Control, and I want the residuals. So there are my residuals. Here is my points. Now, what are we looking at here? Oops, wrong one. Close that one. Okay. What does, let's see, 5 of the residuals are negative. What does that mean about those drives? Okay. So these drives have a negative residual. Okay, so here they are. This one, this one, this one, this one, and this one. All have negative residuals, which means the actual price was lower than the predicted price by that amount. So those points are below the line. And okay, so they want it specific to the unit. So if we look at them, 0.4 was $20 less than the line would have predicted in price. For number 5, at 4 terabytes, we end up with a price that's $122 less than expected from the line. So that's how we interpret this. And number 8's got the biggest, with costing $329.83 less than expected from the line, which means it's going to contribute the most to all of the residuals, the largest absolute value. Are there any other questions we have on this problem? Nope, we're good there.